Hello, today's objective is that we will solve for a missing constant, that plus c, after integrating. In order to do this, we need what's called an initial condition. So the initial condition in this first example, it doesn't always have to be initial, it just has to be some point that the original function goes through. So I usually label these, this is our initial condition here. And you notice it gives us the derivative of a function and it says determine the function given this initial condition. So we're going to start by integrating f prime. So the integral of 12x cubed minus 6x plus 1 dx is equal to, well, we'll just do backwards power rule. This is going to be x to the fourth. 12 divided by 4 is 3. Minus x squared. 6 divided by 2 is 3 also. And then plus x, and then plus c, we don't know what that constant would have been, and this is f of x. So f of x is the integral of f prime of x, and now what they told us was that f of 1 equals negative 6. So what that means is that when we plug in 1 into this function, we get negative 6. So I'm going to show a lot of work here, but you can probably do a lot of this in your head as you go. I put a 1 in for all the x's, and I wrote equals negative 6 where the f of x was, but you could have put that at the end. And then really we're just going to solve this. So we've got negative 6 is equal to 3 minus 3 plus 1 plus c. So it looks like c is equal to negative 7. And we found it. So it did say determine the function. So we need to write our answer, but we found the last piece of it. So f of x is equal to 3x to the fourth minus 3x squared plus x minus 7. And that's it. Our next example, our application problems, are the same idea, just in context of position, velocity, acceleration, or maybe some other word problem. In this case, they give us the formula for acceleration. They give us an initial condition for velocity. And they give us an initial condition for position. So they gave us two initial conditions here. And then they said find the equation for position. So just a quick reminder, position, velocity, acceleration. In order to get from acceleration to position, we would need to integrate twice. So that's what we're going to have to do here. The integral of our acceleration is going to be, let's see, integral of 6t squared should be 2t to the third plus integral of 4t is going to be 2t squared. Integral of 9 is 9t, and then we'll put a plus c. So this is our velocity equation. And then it gave us the velocity initial condition. Velocity at time equals 1 is negative 4. So I'm going to plug in a 1 into all of these. It's just like the last question. Don't know what c is, and this comes out to negative 4. So this is 2 plus 9 plus c equals negative 4. And when we solve for this, it looks like we're about to get that c is negative 17. So we now know that our velocity equation, v of t, is 2t cubed plus 2t squared plus 9t minus 17. In order to go back another step, we're going to have to integrate that. So I'm going to do another line of this. I hope I don't run out of space. The integral of velocity, integral of v of t, will be, well, let's just integrate that again. We're going to have 1/2 t to the fourth, I'm using backwards power rule, plus 2/3 t cubed. I'm sorry, t cubed. I wrote it wrong. Plus 9/2 t squared minus 17t plus another c. This is, of course, our position equation, so this is x of t. This one's really ugly looking, except I'm very excited that the initial condition we get to plug in is 0 for t. which means this is going to go really fast for us. When we plug 0 in for t, all these ugly things just disappear. And it says it comes out to -20, so that means our c is -20. I'm going to finish this up by writing the equation for position, because that's what it asks for. So our answer is x of t is equal to 1/2 t to the 4th plus 2/3 t cubed plus 9/2 t squared minus 17t minus 20. And that is it. We have determined that equation and finished the objective.